Hi there, it's Mr. Wolf. We're back again today doing benchmark 11. I can identify all types of triangles. So this was the very first benchmark we did over triangles. It's actually a really simple benchmark that I think some students struggled with because they viewed it as more complicated than it really is. So we'll try to break it down here and show you how simple this really is. These are some of the terms that you're going to need to be familiar with at the end of this video. So make sure you've got your blank sheet of paper ready to take notes. You need to take a full page of notes at least. And let's get this started. For your sake, it might be best to divide your notes up into a T-chart, kind of like this, and title one side angle measures and one side side lengths. There's two different ways we can identify and label triangles, either by their angles or by their sides. So pause, jot that down on your notes page. Let's get started with the first type of triangle, which is an acute triangle. Acute triangles have three acute angles. You'll recall that acute angles are less than 90 degrees. So all three angles in an acute triangle are less than 90. Okay. Our next one is an equal angular triangle, and you probably already know what that is just by thinking about what this prefix equal means. That means all the angles are congruent. This angle, and this angle are all the same, and if we know that all three angles add up to 180, 180 divided by 3 is 60. So we know each of these angles is 60, and they're all congruent. Okay, the next one is a right triangle, and as the name implies, it has one right angle, usually identified by a box like this. Not always, but usually. Of course, we couldn't have two right angles. If we had a right angle here, that would mean this side of the triangle went like that. Whoops. And that wouldn't even make a triangle. So right triangle is one right angle. Last one by angle measures, an obtuse triangle. Obtuse means greater than 90. Okay, so any angle that's any triangle that has an angle greater than 90 is obtuse. And just like with the right, we can only have one obtuse angle, otherwise it wouldn't make a triangle. So to recap, obtuse, right, equiangular, and acute. Okay. Let's talk about how the sides and the angles are related. Okay, so draw a triangle on your sheet, and I'm going to do the same. Let's go and do, give us a little room here. Actually, get my tool first and draw a triangle. Let's draw a triangle like so. Okay. And if we identify the biggest angle, which is going to be this right angle, and then we also look for the longest side between this side, and this side, we can see that this would be the longest side. Okay? The smallest angle looks to be this one, and the smallest side looks to be this one over here. And you should be able to see the relationship now that the big side is opposite from the big angle. The little side is opposite from the little angle, and the middle side opposite from the middle angle. Okay, so if we give you a problem and tell you, here's the smallest angle, where's the smallest side? Well, you'll just go directly across from it. This has to be the smallest side. This question asks us to classify triangle BDC. That'd be triangle BDC. By its angle measures. Okay, well, we know this is 10, and we know this angle is 100, and I already know that that is above 90. So without doing any more work, what kind of triangle is this? Well, since there's one angle bigger than 90, I know it's got to be obtuse. Okay, let's move on here. It says classify triangle FGH by its angle measures. FGH. And complete the triangle. Well, if this is 60 and this is 60, okay, and I know this angle is 90, subtract the 30 right here, I know that this angle here has to be 60. What kind of triangle has 60, 60, and 60? That's right, that is an equiangular triangle. Okay, let's look at a couple more. Check out all three angles, decide your answer, and then I'll put the right answer. This one, all three angles are less than 90. It's got to be acute. Okay, pause it here, but I see the right angle. It's got to be a right triangle. This one, it's got one angle that's bigger than 90. It's got to be obtuse. This should be pretty easy by now. Let's skip forward here and get into now our triangles by side lengths. Now, go back to your T-chart. We have by angle measures. You should have 4 triangles listed there. Now we're going to do it by side lengths. Okay, and I believe we're going to add 3 triangles here. First one is an equilateral triangle. That's when we have all 3 congruent sides. Okay, put that down in your notes. And if you're like me, you'll draw the picture included with all the markings, and you'll write the definition as well. Okay, so that way you've got a verbal understanding and a visual understanding. Okay, the next type by side length is isosceles. Isosceles means it has at least 2 congruent sides, at least 2 congruent sides. And we see that these markings here tell us that this side and this side have to be congruent. Okay, and the last one is no sides congruent, and that's a scalene triangle. All 3 sides are different. So scalene, isosceles, and equilateral. Okay, and let's look at a couple practice problems on that. It says classify EHF by its lengths. So first things first, let's highlight EHF. There we go. So we're talking about that triangle. I already know that these 2 sides are congruent since they tell me with these little markings. So this has to be 10, 10, 10, and 12. I see 2 sides that are congruent. So my answer, isosceles. Let's do another one. Triangle ACD. So we're talking about this triangle right here. Okay. Tells me this is 18, this is 5. I don't know how long this side is, but I do see a little mark there that tells me this is congruent to this side, so this must be 15. Okay, 15, 18, and 5. None of them are the same, so it's got to be a scalene. Okay. Here's another one. If you want to do it, pause it. Otherwise, I just want to skip forward to our last concept here. Okay. You should be familiar with the triangle sum theorem. What do all the angles in a triangle always add up to? You got it, 180. The sum of the measures of the angles in a triangle is 180 degrees every single time. Okay, so let's look at some triangle angle sum problems. Here on number 1, we're given a triangle and we're given 2 of the angles, 65 and 57, and so we need to find what this third angle is. All right, so we know that the 3 angles of any triangle always add up to 180. Okay, so if we want to find this missing piece, the easiest way for us to do that is set up a simple equation where the 3 angles add up to 180. So 65 plus 57 plus our last missing angle, which we'll just call angle X. Okay, and now we've just got a simple 2-step equation. First, we're going to combine our like terms and add these 2 together. We're going to get 122 plus our X. All I did was combine these 2 right here equals 180. And now to solve for X, we just subtract our 122 from each side. Of course, that's going to eliminate over here. Over here, we're left with 58. And over here, we're left with X. So this angle right here must measure 58 degrees. Okay. Over here, it's the same thing, except they only give you 1 angle, and this symbol here, which you should already know, means that this angle is 90. Okay, so if we did the same thing, we would add 40 and 90 and get our 130 and 180. Subtract 130 is 50. Okay, let's look at just a couple more examples here. These 2 are similar. 20 plus 130 is 150. Subtract that from 180 and we get 30. So this angle would be 30. And you can try that one if you'd like. A couple more different ones down here. Here they've changed things up on us just a little bit, but it's no big deal. Here they only give us 1 interior angle, but they do give us an exterior angle, and we know since these are both on a straight line that they're a linear pair. So this has to be the supplement to 137, which would be 43. I got that by doing 180 minus 137. Okay, now that I know this is 43 and this is 102, I can find this angle. I would add these two together, which gives me 145, and I would do 180 minus 145, and that gives me 35. Okay, but they're asking for this exterior angle, so to find it, I know that this again is a linear pair, so I would do 180 minus 135, which is going to give me 145. Okay, over here we've got something similar. This angle's 35. We need to know what the interior angle is, so it too must be 35 since they're vertical angles. Add these, subtract them from 180 to get this angle, and then find the supplement to get that angle as well. The triangle inequality theorem says, and this, make sure that you pay attention, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so what it's saying is that if you pick any two sides of the triangle, they have to add up to be longer than that third side you didn't pick. Otherwise, it won't make a triangle. Let me show you what I mean. Let's take this length, and let's take this length, and let's take this length. Now, if we try to put these together as a triangle, I think you'll see that we have some problems here. I can put that there. I can put this here. But you're already seeing that that is not going to reach. No matter what I do, if I twist it like that, it's not going to make a triangle. So these two shorter pieces have got to add up to be at least as long as this long piece. Otherwise, they won't touch. Okay, so a problem on that might look like this. Do these segments make a triangle? Well, take the two short ones, 3, and since the other two are both 6, it doesn't really matter which one we pick. So we'll take these two. We know they add up to 9. Is that greater than 6? Yes, it is. So it has to make a triangle. Here, we got 3 and 6 are our two shortest sides. They add up to 9. Is 9 greater than 16? Absolutely not. So this won't make a triangle. And one more. We got 13, and we'll just use this 16. Those add up to 29. Is 29 greater than 16? You betcha. So it will make a triangle. Okay, so let's get to the end here and let's summarize. All right. Easy way to remember is with your T-chart. You got triangles by angle, and you got triangles by sides. Okay, by angle, we had acute triangles, we had right, and we had obtuse, and we can even throw in that equiangular as well. As far as sides go, when no sides are equal, we call that scalene. With at least two sides equal, we call that isosceles. And when all three angles are the same, we call that, or excuse me, all three sides are the same, we call that equilateral. Okay? We know that all triangles, the angles add up to 180. And we also know that the triangle inequality theorem states that any two sides have to add up to be greater than that third side. Okay, you should have good notes after watching this video. And if you have any questions, as always, text, email, call me, whatever you need to do. I am always here to help. Signing off, Mr.